Hi all, I was watching a YouTube video where a flat earther was trying to tell us that perspective causes the sun to set. I never understood that, how it could get below the horizon, but never mind about that. I want to instead address a different issue, and that is that I've seen quite a few of these where they use like lamp posts or fence posts or something like that to tell you that perspective causes things to disappear and the path of the sun is just like the top of these lamp posts or fence posts or something receding to the vanishing point. And while I get that idea generally, I don't think we can apply it to the sun. And that's because the height of these lamp posts or fence posts or whatever compared to the distance away that they show them is not very tall. So when we're talking about a 5,000 kilometer high sun, we have to be thinking about how far away something would have to be to look really small. So I live in a city where they have a building that's over 600 feet tall, and we can see it, the top of it, from quite a distance away. So I don't think that you can say that things disappear to the vanishing point without acknowledging the comparison between how big it is compared to how far away it is. So this is the video that I was talking about. Have you seen this guy? He's written a lot, created a lot of videos about all kinds of things. I think this is another one of those same videos where he goes on and on about perspective and how perspective causes things to appear to get lower in the sky as they get further away. You can see another one here. He's doing the old lamp post argument. But he tried to do this thing with lighters, and I thought, well, that's kind of gave me an idea of something that we can explore. So what I want to do is show you a little bit of this guy's video. I've got a little clip here. The whole thing is, you see, is about 3 minutes and 45 seconds, but I just want to show you if I can get my computer to cooperate. There we go.
You can see that all the lighters appear to be the same height, which they are. But the moment we go down below that level, all the lighters appear to get shorter and shorter over distance. And they will also appear to get closer and closer together, even though the distance between them is about equal.
Okay, so that's what I wanted to show you, where he says the distance between them is about equal. And I captured a still from the video to help you understand what he's talking about. There's a point where he kind of pans along the length of the table where you can see all of the lighters in a row, and they are about equal distance apart, and there are 5 of them. And in this still, you can see that the length of the space between the lighters is about 3 times the size of the height of the lighter. And maybe it's not exactly 3 times, but it's pretty close. So if we were looking at this as just an experiment in explaining perspective like he's doing here, that's fine. But if we're trying to build an argue about the reality of the Earth, then we have to think about the height of that lighter as representing the altitude of the sun. And if the sun is 5,000 kilometers high, then that height of that lighter has to represent 5,000 kilometers. And that distance across the table there has to be to the same scale, so that would be about 3 times that. That distance would represent 15,000 kilometers, and there he has 5 lighters in his row, so he's representing 75,000 kilometers. Now, anybody who's familiar with the flat Earth would know that the flat Earth is about 40,000 kilometers across. And 40,000 kilometers is bigger than or not as big as that 75,000 kilometers that he was trying to represent with his row of lighters. But so the way I figure it is that we can take some lighters, and I got a couple. I didn't want to buy a bunch of lighters like he did, but I got a couple of them, and I figure we can lay out the size of the Earth approximately using the height of the lighter. Now I didn't get the same brand of lighter. I just got this little cheap one from the gas station. But if we say that this lighter represents 5,000 kilometers, then I should be able to lay 5,000. I should be able to lay 5,000. Lay 8 lighters across the table here and represent the flat Earth. So here's the flat Earth model. It's supposed to be 40,000 kilometers across that white line. So I'm just going to come over here to the table. You can see I've got the lighter. I got one with flowers. Isn't that beautiful? So I'm just going to lay them across like here and try to stand up so you can see. Get this one right on the edge of the table. And then I'll just go 1, 2, 3, 4, 5, 6, 7, 8. So the thing about scale is it doesn't matter how big your unit is. All we're trying to do is just get the ratio of the height of the lighter compared to how far it is across the table. So that's about how far it is. Let's see. Can I twist the camera so you can see it? All right, there it is over there. You can see it looking across. I'll look at here. I'm trying to get the camera angle like right on the table like that. That's about what it looks like if you're looking all the way across the Earth, about like that. Okay, but that's not really what it looks like. So I want to go on here. So that's, I guess I already showed you that. Using lighters to scale, it's about 8 lighters across. So from here across the table, I laid out 8 lighters until we reached over to that side of the table. Wish I had more lighters, but it's not worth the money to me. But the problem with that is that that's not really how we see. There's nobody on the Earth, at least except for a few research scientists, I suppose, but there's nobody on the Earth who's over here looking at the sun that's over there, right? The flat earthers will tell you that the Earth circles the sun circles the Earth at either around the Tropic of Cancer or the Tropic of Capricorn, and somewhere in between that. Here they have it roughly on the equator. So what they're saying is that somebody over here, looks like Southeast Asia somewhere, like Thailand or something, and they're looking, from someone looking from over here, looking across this way, wouldn't be looking across the full 40,000 kilometers of the Earth. That's not even half of that. That's more like 18,000 kilometers. So what do we get when we do it that way? So 18 divided by 5,000 kilometer sun is only going to be about, so here I'll put something over here to mark where that was, and then come back here and I'll lay out. So 18,000 kilometers, how many lighters is that? Let's do the math together. 18,000 divided by 5,000 is 1, 2, 3. So let's, sorry, I lost count here. Let's do it again. Right on the edge, 1, 2, 3. That's 15,000. And then 18,000 would be about half, 3,500. Or 3.5 lighters. I'm going to do a little bit more. Okay, so that's what it would look like down here. So let's get it down on the ground. Oh, I have to tilt the camera up a little bit to see the lighter. So when we have the perspective built to scale, then the lighter is going to look like that. The sun would never get lower than about like that in the sky. Now you could say, well, John, you're doing it wrong. You should have it a little further away. So I don't mind. Let's do, 5 lighters away. Still, you're looking up, seeing that in the sky, the sun's never getting to the horizon. So I want to show you what he says about this. with his other video here. Let's take a listen to what he says.
Angles of the moon and the sun, and how that would be impossible on a flat Earth.
He's arguing here with another person who's trying to prove that he's sort of arguing back and forth with somebody. So let's listen again.
Fred on the ground.
Fred is his imaginary point of view from the ground.
Sun on the flat Earth is a sun maintaining a consistent height above the flat Earth, but
consistent height like the lighters.
It appears to sink to the horizon. So when he then demonstrates that the angles from his two-dimensional external frame of reference do not match what we should see according to the globe Earth way of looking at things, he is completely misrepresenting the way we actually see it. And when we see the angles between the observer on the ground, the moon, and the sun represented in this external reference frame, he's using angles from his two-dimensional external reference frame, but he didn't put the observer into the external reference frame. He did not put in the angles at which we see the sun set. If the sun and the moon are on opposite sides of the flat Earth, then from the observer's perspective, that sun has already sunk below the horizon. You simply cannot debunk the flat Earth by using the false external reference frames that are used to illustrate the globe. And this is why the globe is wrong, because we are constantly being told to consider the globe from an external two-dimensional frame of reference, when really what we see is a four-dimensional internal frame of reference, and that is never ever translated into illustrations of the globe. So, globeheads, you're just two-dimensional thinkers. When flat earthers talk about a flat Earth, we're not talking about a two-dimensional plane. We are talking about a multi-dimensional plane.
All right, so he's saying we need to get our 3D model with multi-dimensional considerations, measuring everything just the way it ought to be, and we'll take his idea of using lighters. Whoa, don't want to go too low there. And there it is. Everything's to scale. Everything's just like he said we need to do. Three-dimensional perspective on what he's talking about. So, Mr. Phuket, or however you pronounce your name, what are you going to say about that? You're wrong.